Welcome to The Explainer. Today we're tackling a concept that silently dictates almost every single aspect of our modern lives. Seriously, think about it. From the loans we get approved for to the jobs we land, right down to the medical care we receive. We're looking at the fascinating and honestly sometimes scary intersection of AI, algorithms, and ethical risk. We're drawing all of this directly from Dr. Erlander Jansson's master-level work on ethics and behavioral economics. Now, society tends to operate on a really dangerous assumption. We assume that just because a machine is crunching the numbers, the outcome is inherently neutral and perfectly objective. Well, today we are going to completely shatter that illusion. Okay, let's dive into our roadmap for this explainer. We've got 5 key areas to cover. First, the myth of neutral AI. Second, the actual math of fairness. Third, the accountability void. Fourth, generative AI's new risks. And finally, governing the AI future. Let's get right into it. Section 1. The myth of neutral AI and uncovering those hidden biases. So, we live in a world where automated decisions are absolutely everywhere, and because these machine learning models are often genuinely more accurate than human judgment at certain specific tasks, we've developed this massive collective blind spot. We kind of just equate mathematical processing with moral neutrality. But ask yourself this directly: is an algorithm naturally objective? When a bank uses a statistical model to approve a mortgage, or a judge uses a risk assessment tool, is that math magically insulated from human bias? The short answer is no, absolutely not. Behavioral insights show us that the exact same human biases that produce discriminatory outcomes in the real world, they just get directly encoded into these models. There are actually 3 distinct sources of algorithmic bias that we really need to understand here. The first one is pretty intuitive: biased training data. If a model is trained on historical lending decisions where certain groups were unfairly denied loans, well, the algorithm just learns to reproduce that exact same historical prejudice. The second is proxy discrimination. A really famous example of this is Amazon's abandoned resume screening tool. It systematically downgraded resumes that contained the word women's, like Women's Chess Club, simply because it was trained on 10 years of hiring decisions from a predominantly male workforce. The algorithm wasn't secretly prejudiced, it was just acting as a highly efficient mirror, reflecting a prejudiced world right back at us. But that third bullet point right there, fairness criterion choice, that is the true master-level concept we need to explore next, because you cannot fix that one with just better code. That brings us to Section 2, the math of fairness, and Sholdakova's impossibility result. Okay, so when we say we want an AI to be fair, what exactly are we asking the math to optimize for? Here are 3 entirely reasonable mathematical definitions of fairness. Demographic parity basically means flagging the exact same proportion of people in every group. Equalized odds means the false positive and true positive rates are equal across groups. And predictive parity means the tool's positive predictions are actually correct at the same rate across groups. On their face, you could make a really strong, valid ethical argument for every single one of these. And this brilliantly illustrates a core problem, mathematically proven by researcher Alexandra Choldachova back in 2017. Her impossibility result shows that when the base rates of an outcome differ across groups, you literally cannot satisfy all 3 of these criteria simultaneously. For example, look at criminal justice risk assessment tools like Compass. Recidivism base rates differ across populations due to historic policing patterns. Because of that reality, achieving equal false positive rates, equal false negative rates, and equal predictive parity all at the exact same time is a mathematical impossibility. You literally have to pick one over the others. So here is the absolutely crucial takeaway. Because we cannot mathematically have perfect fairness across all metrics, deciding what a system optimizes for is fundamentally a human value judgment. It's a normative decision, not a technical one. But here's the crazy part. In most real-world deployments, this massive ethical choice is just embedded silently into the objective function during the training phase. It's completely invisible to the actual people whose lives are being judged by it. Let's move to Section 3, the accountability void. When things go wrong, who is actually to blame? Think about it. If the machine encodes our biased value judgments and inevitable harm occurs, who takes the fall? Who is illegally or even ethically to blame? In organizational ethics, this is known as the problem of many hands, which is a concept first named by Dennis Thompson way back in 1980. Imagine an algorithmic system flagging welfare claims for fraud. The data scientist chose the architecture. The procurement team bought the software. The operational manager deployed it. No single person ever intended to cause discriminatory harm, and everyone just did their specific, narrow job competently. But the technical complexity and the sheer scale of these models heavily exacerbate this diffusion of responsibility, and it leaves us with this massive accountability void. Now, regulators often try to fix this accountability void by requiring a human in the loop, someone who can review and override the machine. That sounds great in theory. That's the ideal. But the behavioral reality is a little something called automation bias. Imagine being a mortgage underwriter. You're reviewing 200 algorithmic recommendations a single day, and each one is presented to you with a high confidence score but absolutely zero accessible rationale as to why. The probability of that human worker meaningfully overriding the machine, it's incredibly low. Under that kind of cognitive strain, human oversight rapidly devolves into just a rubber stamp. Just listen to this quote. "A nominal human in the loop may provide legal cover without providing ethical protection." Wow. This creates the perfect conditions for severe ethical fading. The machine has already made a judgment. The institutional pressure pushes the worker towards simply confirming it to save time, and the human operator is effectively stripped of any genuine, independent moral reasoning. Section 4. Generative AI's new risks and the scale of opacity. Okay, so everything we just discussed, that all applies to standard statistical prediction models. But generative AI, like large language models and image generators, carries these exact same behavioral risks, but with unprecedented scale and a really deep epistemic opacity. It introduces its own unique risk profile, primarily through something called hallucination. This happens when a model produces confident, highly fluent text that is just entirely fabricated. Think about an AI citing court cases that literally do not exist. This is so dangerous because it directly exploits our human cognitive biases, specifically the availability heuristic. Because the output sounds totally plausible and reads beautifully, our brains use that fluency as a highly misleading signal of credibility. We trust it because it sounds smart. And here is the truly invisible danger of generative AI. Imagine a compliance officer using an LLM to figure out if a proposed business transaction is ethical. They aren't just automating a math calculation anymore, they are dangerously outsourcing the framing of the ethical question itself. Delegating that framing to an AI system doesn't somehow reduce the decision-maker's moral responsibility. It actually removes the very moment that moral responsibility is supposed to be activated in the human brain. Finally, Section 5, governing the AI future and how we reclaim control. So how do we climb out of this mess? How do we actually build actionable institutional ladders out of these deep ethical and mathematical risks? Well, we need robust algorithmic governance. Researcher Finale Doshi-Velez and her colleagues proposed this brilliant 3-level accountability framework. First, you absolutely need pre-deployment audits by independent technical reviewers. Second, you can't just launch it and leave it. You need ongoing monitoring for disparate impacts as the system interacts with real-world populations. And third, you need rock-solid institutional governance structures that assign clear, undeniable responsibility for each of those activities. This is what genuine auditability actually looks like. And look, we are definitely seeing the law attempt to catch up here. Under the European Union's GDPR Article 22, individuals actually have qualified rights against being subject to solely automated decisions that produce significant effects on their lives. Plus, the new EU AI Act takes a risk-tiered approach. It demands mandatory conformity assessments and transparency for high-risk systems, like law enforcement or credit scoring tools, before they are ever even deployed. But remember our core lesson from today. Legal compliance does not automatically equal ethical adequacy. A system can check every single legal box and still be ethically disastrous if it creates automation bias or if it hides behind mathematical opacity. I want to leave you with this final provocative thought. We've seen today that AI is not some neutral, all-knowing oracle. It is a choice architecture built by humans. It is filled with our biases, our impossible mathematical trade-offs, and our accountability gaps. So, knowing that algorithms are coded with very real human limitations, how will you ensure you don't surrender your own independent judgment the very next time a machine confidently tells you what to do? Thank you so much for joining me for this explainer today. And remember, always keep questioning the code.